fulfills our demand as per the requirement of the products and what we thought of that it should perform in this manner. Actually, this composite materials, my lecture and discussion will be limited to polymer matrix composites because there are other metal matrix composites, ceramic matrix composites which people are using it. But I will focus and try to talk on polymer matrix composites mainly. So this is about brief of and at the last what work we have done, whatever the laboratory we have developed, what are the instruments available, those who want to use it, I'll just give the brief on that. So this is a brief of this. So as you can see that this is the Stone Age, we can say starting from prehistoric to 2500 BC, that is hard and brittle materials used to make earthenware tools and weapons. From here we have started. Okay, so these are that is known as the Stone Age tools. One of the most important advancement in our human history was the development and use of these tools. The first tools were made out of the stones that we know, and thus historians refer this the period of time before the written history as the Stone Age. So from this we have started. These are the bronze, then after 2500 BC to 500 BC, and then bronze tools, then Iron Age Iron Age tools. This is the technical application started slowly. That is the world first cast iron bridge. Those who are civil engineers, right now we never thought that is cast iron. We always want ductile. It is a brittle, but it was developed. Cast iron bridge. It was built over the river Severian at the Kolbekdul in 1779. Afterwards, the 19th century, it was steel, that is alloy of irons became available. Means as per the improvement in the property of the steel, advancements that is required. This had increased the strength and lowered the brittleness. That was the advancement. This allowed larger structures to be made. That was the significant achievement. And then after the carbon fiber, I will not say carbon fiber, but the fiber reinforced composites that will, but mostly the carbon fibers. 20th century composite materials, that is still we are only focusing on more towards synthetic fibers, glass fibers, carbon fibers and other fibers. But we have to thought of, because CO2 emission and other sustainable development also, we have to thought of how we can reduce all these things. So people are doing the research towards sustainability also. So 20th century, composite materials and plastic became available, which provides the greater strength and flexibility together with a low density. Okay, that was the main attraction. This proved to be a particularly useful in the aircraft and civil engineering industries. So this is about the brief of the materials, and we have reached to the composites. Now, what is composites? These are the handbook definitions, but without that also we can see that composites means, as a word also we can say that composite means anything that we are combining. Similarly here also we can say that the composite materials are, it is a macroscopic combination of two or more distinct materials, but having a distinct recognizable interface separating them, as it is a macro scale. So I will take 2 minutes on this interface. INTERFACE. Another word that we should know as an engineer, though civil or mechanical or metallurgical, that is interface. INTERPHASE. So when we are preparing the composites, hello? Okay. Now it's okay. So I was talking about interface. Okay. Okay. Generally, the habit is that moving in the classroom and taking the lectures. Okay. So interface, that is FACE. Interface. INTERPHASE. So this is very, very important because it's near to my heart also, because the PhD which I had received from REC Surat, that is SVNIT, I had worked in the interface and interface. Because when we are preparing the components, during the curing stage, the third phase is created. We never take care of that. We are only aware of the property of the fiber and matrix. And we know the rule of mixture EF, CM, EM. But we never thought of that, how the interface is playing the critical role in the design of composites. So we had generated the elastic interface modulus values for the interface. If we have the property of, I think, I'll use this.
Correct. You can remove that. That is right. No need for mic actually. Your voice is satisfied. Just your normal voice is satisfied. Yeah, no need for mic, sir.
Okay, I think it's
Whatever.
So interface and interface, basically, when we are preparing the composites, we are adding two mixture, matrix and fiber. Fiber may be in any form, whether in the fabric form or random fiber or anything. So once we mix it, curing starts. During the curing, at the boundary of the fiber, third phase is created. That is interface. If it is, generally it is an interface always. If it is a two-dimensional boundary, we call it as an interface. Because for stress transfer, we require the medium. Because fiber is a load-bearing member. So we have developed the equations for the EI, interface elastic modulus, using various mathematical technique. But that is through experiment, not only mathematics. The property of the fiber is known to us, or we can test it. Property of the matrix is we can develop or we can test it. By combining this, the well-known equations, rule of mixture, inverse rule of mixture, or as per the laying sequence, we can have the property and we can incorporate this thing. So that is a combination of interface and interface. So that is very, very important. So these are some of the definitions that it is a combination of two materials. Now, why this field is gaining importance since 10-20 years. So the former president of India, Dr. APJ Abdul Kalam, addressed an international conference and exhibition on reinforced plastic organized by FRP Institute in March 2011. He quoted that based on market survey, growth trends of composite material and product application in India is 1/8 of the China and about 1/10 of the Europe. But now this situation has little bit changed and we are improving in this. This is old data, but this is the sentence that he has used in that conference where I was present. It is essential for the Indian composite materials manufacturer to evolve strategies to bridge this large gap through innovative research in materials, process and product design, which is vital for meeting the needs of cost-efficient manufacturing for being competitive in the global market. What is happening right now in the industry? People thought of, or industry or as a researcher also, people thought that this component I want to replace metal as it is, and they try to develop the composite as it is, because both are different things. One is completely isotopic material, one is maybe a transversely isotopic, or it may be an anisotopic material. So we have to thought in that terms, and we should how easily we can develop the component using appropriate manufacturing process, because all component there is no universal way. Every component we have to prepare as per tailor-made process or applications. These are for simple products. For special applications also we need specialized machinery, etc. So this is the basic thing, constituents of PMC, polymer matrix. Now, as an engineer, we all know that is what is isostress condition, what is isostrain condition, and what is isostress condition. If I want to try to explain in a simple way, suppose fibers are placed and loading is in the direction of the fiber. Okay, so strain will be constant.
in the fiber also, in the matrix also, and in the composite itself. So whatever the equations we know that is developed in the theoretical concepts, these are the equations that we have developed, that is known as rule of mixture or inverse rule of mixtures. So this topic I was discussing that mostly we are using this equation VM EM plus VM EF, that is composite elastic modulus, because whatever the composites we develop, if you want to make it structurally stable, we have to find that tensile properties or flexural properties, impact and other properties. If it is passing those standards as per the ASTM, whatever the standards are defined, then only we can use as a in our product. So these are the EC. So what we have done is we have incorporated EI plus EM. Sorry, EI plus VI. That is interface fraction of the volume interface fraction, as well as the interface elastic modulus. So that we have done long back in 2004-5. Afterwards, there are many advancements. These are isostasis condition for inverse loading, means perpendicular to the fiber. That's why generally we see that whenever the people develop the composites, they use various, here the roll of textile comes. We have different fabric. In that different patterns are there. Plain weave, twill weave, sharp weave, whatever it is. Okay, so as per the sequence, so we try to develop we try to balance the properties so that it will come near to isotopic conditions. That is our target. That's why role of textile is very important. Nowadays, the next page is always we are interested in fabric or layer, that is known as lamina. Instead of that, now 3D fabric. That is also one more concept coming up, so that as it is, it can be tailor-made whatever shape we are required. So these are the advancement in terms of textile. So here textile, chemical engineering as well as mechanical manufacturing process all, and applied mechanics, that is testing the composites, all play a crucial role. I'm not going into the detail of the theory and other things. Thermosets and thermoplast, all we know. Now, role of fiber. What is the role of fiber? That carries the plane loads, provides the stiffness and strength, reduces the thermal coefficient of expansion. If we talk coefficient of thermal expansion, various space applications where we require low coefficient of thermal expansions. So we can thought of, because lightweight is also important, and we have to thought of that how we can reduce the coefficient of thermal expansion. So that is very, very important. So each word we have to touch, and we can thought of the applications. That is the main idea behind this. Then role of resin, that is bonds and holds the filament in place. It provides the transverse strength, act as the load transfer medium, provides the interlaminar toughness, and provides the durability. This is the role of the fiber and the matrix. Now this is a very vague comparison, that is steel and composites. Now advantages of composites in general. It will be different for synthetic fiber composite, it will be different for natural fiber composite, but it is in general, it is mentioned over here, that is, it is a great freedom of shape. Because in a single piece, whatever we can thought of, that as per the open mold or closed mold, we can prepare lay down the fabric and we can prepare it, any shape. If we have to prepare from metal, we have to perform the primary manufacturing process, that is casting and other things, and then secondary manufacturing process, either machining, any kind of machining operations. So these are the two processes, and it involves lot of cost also. But at the same time, here the fibers and other things also, we have to see that how easily it is available and how we are laying down the patterns. So that is very, very important. So great freedom of the shape. Then high degree of integration is possible. Whatever the insertion or any development is required, we can incorporate. Material can be tailored. Excellent fatigue endurance concerning number of load cycles. That is variable stress is good compared to other same weight materials. Excellent chemical resistance because it is non-corrosive. Excellent weather and water resistance. Composites have RAM features, that is radar absorbent material. So that is very important. That's why it is used in various applications, aerospace and other. So we can thought of that what kind of waves it has to catch or as per that application. So nowadays it has find many applications in RAM. That is very important. Then excellent impact habits. Mostly nowadays due to Make in India, now in our defense sector, this is playing crucial role. That is excellent impact habits. So whatever the armaments or whatever it is to be developed, they are thinking of to develop the various composites or wearable devices using this. Excellent electrical habits, dielectrical habits, great thermal isolation habits, fire retardance habits, and high temperature performance, etc. So now designing with composites. Okay. So I'll start with it. A common mistake designer makes when replacing the metal with composite part is to trying to make them look as the same. We don't have to see that whatever the shape is available, if whatever shape we think it will work, we should try that thing. That is, most composite materials have anisotropic properties. Glass fiber itself is a isotopic fiber, single. Glass fiber is an isotopic fiber. Others are not. Okay. The level of anisotropy is related to the material and manufacturing process which we are using. So this is as by chart, some theoretical aspects. You can see the various phases for the composites and polymer and forms and other materials. So you can see that two examples are given. That is, one is welded steel tubing. That is 21 pound, and then it is compression molded part. It is 10 pound. So it is a monolithic design. It can be thought of. Earlier part, welding is required separately, machining is required, but here we can thought of that it can be developed as a molded parts. So this is just for initiation purpose. How we can thought of? It comes by experience. When the engineer is recruited in the industry, what if they have worked, they have prepared the composites, and then only it comes by experience. So same way here also, you can see that the composite designer has to achieve the same stiffness which was accomplished by changing the cross section. Here it's a circular, because metal it is very easier to prepare, machine the circular rod. Okay, so the designer also had to consider the attachment of matting part. In this case of the example, a few of the matting parts have been molded directly into the rod. You can see that this edge section is created. Stiffness with section geometry. It creates for developing the stiffness that will enhance its stiffness. So that is this kind of things our pure applied mechanics subject here. That is edge section, eye section, etc. That we have to thought of, and then we can incorporate all these things. So this is a small examples I have taken. Okay. Factors influencing composite manufacturing includes robotics, automation, autoclave, out of autoclave process, thermoplastic composites, composite 4.0, and additive manufacturing. The manufacturing world like to think composite fabrication as a single global entity that operates to serve its consumers' needs with a variety of highly engineered parts and structures. In reality, however, the composite industry application is an amalgamation of many highly vertical markets, that is aerospace, automotive, marine, consumer, wind, etc. Composite material can meet such diverse needs because they are so diverse themselves. The array of fiber resin. Array of fibers means there is a variety of fibers available. Number of fibers variety, and people are developing it. And not only fibers, from fibers, various kinds of mats, fabric, etc. Whatever the shape that is, then tooling, process, finishing options available make possible fabrication of nearly any composite parts, nearly any industrial applications. So this is a rough view I have taken from this magazine, that is US Composite Market magazine. This is a it will give the all these technologies spring from help drive a highly dynamic and fast changing composite industry. That is transportation, that is mostly is wind energy, then transportation, infrastructure, building constructions, chemical corrosions, electronics market, defense, aerospace, telecom, etc. So these are the consumption of the composites. This is a one comparison, that is consumption of composites in terms of various field, that is transportation from 2014 to 2020. It has in almost all the field it has increased. That is from transportation overall it is from 8.2 to 12. That is the percentage. Sorry, it is in terms of tons, I think. Okay, it's shipment, total shipment. So now comes to application parts of the composites. This is one way, aerospace. You can see, have a look on the diagram, various components. That is CFRP center wing box, CFRP wing ribs, CFRP rear pressure, CFRP sections. One application I remember, cowling, you know, engine, jet engine cowling or anything. So DRDO has earlier in Ranoli there was a unit, Reliance. So they have one requirement that fiber volume fraction should achieve around 65%. That is in carbon fiber. So that we were able to develop using VRTM process, vacuum assisted resin transfer molding process, because that has to be very stiff and it can withstand any load. So that cowling and other structures can be developed same way using carbon fibers. One more thing is that this composite field, like when we were studying in first year of engineering, after beginning subject, factor of safety. We all have heard the word factor of safety, 1, 2, in our numerical also we were taking. But here that concept is not coming. So if you give, suppose consumer ask you what is the reliability of this product, because if you are purchasing something, what is the reliability of this product, how it will perform, especially in aerospace engineering, A bias application and B bias application, that is 99.9% reliability and 95% reliability. So we have to make sure that it will perform. So what we have to do is, these are weak bond. It will not follow normal distribution in number of tests. It will follow the Weibull distribution. Suppose we are testing 100 samples, out of all the 100 samples, it will follow the Weibull distributions. So generally what people are taking, they test the 5 sample and take the average. That is a simple method they are taking. But here weakest element we have to take. So that then only we can specify that it's reliable. So that concept, one very good paper in the long back we have published in terms of this Weibull distribution in Materials and Design Journal. Right now it is very renowned journal in elsewhere. So that paper is used by industry also, and that is instead of factor of safety, reliability based evolution. So that code we have developed using C programming, and once you give the 100 samples, suppose you have tested, it will give you one value that you can take as a design. Either you want to use in ANSYS software or any other. But it will give idea that whatever you are designing, it is perfect. So that way also we have to think. Then comes the automotive market. Whatever we can thought of, we can replace it after testing it. That is the scope in automotive industries. Even in high-end cars, they have used to reduce the CO2 emission, because production of carbon fiber, glass fiber, ultimately we are adding pollution, nothing else. So people are trying using flex or any other, but people have achieved up to, suppose it is 80 gigapascal for glass fiber composites, but with flex around 25-30 gigapascal or something, reducing the glass content and other things. So that way people are thinking of to reduce, because ultimately production of glass fiber, production of carbon fiber, ultimately it is a pollution related activities we are adding. Okay. Compared to production of the iron and other, it is less, but ultimately it's not fully environmental friendly. So we have to thought some sustainable technologies also. So these are some of the applications. You can have a look, various parts, bumpers, etc. Okay, especially stiffness is more important. We can thought of. You might have seen on the highway guide rails that shape as per the okay. Long back we have prepared from glass fiber also. So that can be replaced. Not only that, now people are thinking of same way that barriers using dampers, so that if vehicle is striking, it will come back and it will not be damaged. At least some damping mechanism should be there along with side. So this kind of application, that is known as eco-safe guide rails. In Europe they have just implemented. I think few days back Nitin Gadkari sir has also discussed regarding this guided replacement from metal to this. So that is slowly coming up in our Indian context also. These are some of the BMW. These are fiber bumpers. Then boat building and marine. These are old applications. People are already using it. Some more applications. 3D printed composite structuring in Nashville. I'll take few minutes on this 3D printing. Recently, as ma'am has told, we have developed the ankle mechanism, foot ankle mechanism, using software and various combinations. Once it was finalized, with the help of orthopedic surgeon, we have developed, we have prepared, manufactured it, tested on patient, and successfully it has passed the gait cycle, walking cycle. And then we have few days back only we have got the pattern also, that is for leg. Now that was through plastic only. Now we are thinking that to develop with carbon fiber. So now we have started working on prosthetics and orthosis, because day to day by injury, accidents are increasing like anything, and especially for older age peoples, more support is required for day-to-day life. Suppose person is going with hand stick or something, but that weight itself is so much that they can't walk. Can't be thought of that simple mechanism, that lightweight, but it is having some good stiffness. That is also one application. We always thought in respect to technological application or industrial applications, but social day-to-day applications also, various applications we can see. So lot of work we have done in manufacturing. We have done work in the tribology of composites, primary manufacturing of the composites, secondary manufacturing of the composites, metal matrix composites also, and then later on, since 3-4 years, started the prosthetic and orthotics, especially prosthetics now, right now, not orthosis. So that way also it can be. So now we are planning that we will, if facility is available, we will be printing those things and it will be available, so that it will reduce the time, but at the same time initial cost will be high, but once it is commercialized and it will be in the market, it will be helpful. Okay, I think most of the people, they are replacing knee. At that time doctor will give various options, that these things are there, titanium and other things also, so that this is very good, it is biocompatible, etc. So biocompatibility has to be proved first, that it will work in the human body. That is the test to be performed for these composites once it is to be developed. So So it is a long process. That work was submitted and we have started in 2020. Now after 4 years, we have got the success. So this is the 3D printing. Now electronics. Those who are from the electronics fields, I think these terms will be familiar for them. Consumer demands in the electronics market for greater durability and more features at lower cost, and original equipment manufacturers, that is thinner, lighter, more energy efficient devices. So you can see that one example is written, that is Galaxy Note 9, that which launched in 2018. It employs a water carbon cooling system that is said to allow the phone to run more smoothly during heavy use. Sometimes we see that it gets hot. Suppose we are taking more pictures during daytime or something, and then it shows that it will not take the picture or something kind of. So this kind of things. So energy efficiently dissipating heat mechanism, that is possible with this. Then interconnection, electronic enclosures, printed circuit boards, interlayer dielectrics, electrical contacts, connectors, heat sinks, housings, etc. All these things now people have already developed and it is in use. Okay. Then oil and gas industries, already they are using, and most of the pipes, etc. it is already replaced with this. Pressure vessels also. Even in the Rajdhani, that those tanks are replaced by glass fiber tanks. Now people are working for this CNG cylinders for two-wheeler. But now as electric came into the market, that research has slowed down. And renewable energies. Then sports and recreations. This is a big market. It's a cycle, but the cost may be right now it is 2 lakhs, 2.5 lakhs with carbon fiber. It's just for laser purpose, not right now commercially. Then utility and infrastructures. Now some of the slides I had kept from the Indian composites context. That is, there is a great scope for the Indian composites fabricator and raw materials. Various RTM processes. You can see demand in lakhs of metric tons from 2013 to 2018 and 2019 to 2023. So it is increasing day by day. These are the manufacturing processes. This is resin market, and mostly pultrusion. I think you may not, some of the people may not be aware what is pultrusion. Continuous sections that is to be prepared. That is, suppose edge section is continuous or whatever it is. Then RTM, resin transfer molding, vacuum assisted resin transfer molding. Most of the people right now in small scale industries, they are using hand layer. Some of the major challenges that is for the Indian composite industry are as R&D activity needs to be increased to drive new composite products and applications. What we see that, suppose I am a mechanical engineer, I had studied only types of composite in 3rd semester in material science subject, nothing else. So when I started 2003 working on composites, as a coursework, I have to study everything. So this itself curriculum gap it is observed. But nowadays some electives and other things are coming, and combination of various branches also it is coming. So it will be very easier to implement all these things. The need to eliminate lack of awareness of composite in Indian industrial world and a prevailing low knowledge base. You might have observed those. I think if anybody from industry, they will say that if you want to hire any engineer, they are not aware with the basic terminology of the composites. How you will work with the labors in the industry, so that proper guidance, proper certification courses, etc. it is required for composites. The need to promote standardization of end-use products. Like if I'll talk in terms of mechanical machining data. What kind of drill tool I have to use to cut steel or this. So machining data it is available. But for this purpose, suppose I want to make the small micro hull, because these materials have to be used in aerospace or space industries. If hull is not by naked eye, we cannot see that it is it will see that it is a perfect hull. But once we make the hull, if small crack, it may damage the complete components. So what kind of delaminations are there? While we are drilling, what kind of thrust force is developed, etc. These are various interesting research studies that is developing. So those things are very, very important that we work on each criteria. Even this small topic, machining. People will say only it is a drill, what is happening? But once we see on the microscope what kind of cracks are developed, what is the delamination at entry, delamination at exit, what is the surface roughness, because these are the parameters which creates or accelerate the catastrophic failures. So these are the things. Then IP activities, we are not patenting our products. Limited number of scientific publications, carbon fiber dependency on import markets, but now I think slowly it is emerging in India. Need to improve quality conscious among small FRP, GRP composites. So I'll just end with the composite materials. We can say that it's a composite material, it is a material of the century. So this is my favorite sentence, that life is a composite of happiness and sorrow. I'll have small presentation on facilities available. Do we have time for participation? Okay. As I was told that whatever the facilities available, this is a composite processing research lab in our Department of Mechanical Engineering, Faculty of Technology. We have vacuum assisted resin transfer molding setup. We have 3D microscope. We have hot air oven, muffle furnace, compression molding with temperature pad, computerized drill tool, dynamometer. It is a piezo base, so no calibration is required. Filament winding, it is a prototype base, hand layup facility as per the requirement. We are having veining scale, thermal conductivity measurement developed in lab itself. So these are the some of the view, thermal conductivity measurement apparatus, VRTM setup, hot air oven, 3D microscope. This 3D microscope, that is an image processing actually. We capture the image using MATLAB and other tools. We find out what is the delamination, what is the damage during machining that we have carried out in composites. That it will give. This is the compression molding with temperature pad. Then muffle furnace. Muffle furnace is used for finding the ignition loss. We want to find the fiber volume fraction. We can find the fiber volume fraction. Then prototype filament winding machine. This is the drill tool dynamometer. It is to be used with vertical machining center scale. These are some of the achievements of our laboratory. We have research projects on investigations of process parameter in dealing of fiber reinforced composites. That is through SERB. That is already completed. Then we have Bush Coast grant on VRTM. We have for metal matrix composites also we have received a grant from Bush Coast. Then recently, this is through DST first we have procured the 3D microscope. Then research project on study and development of natural fiber based composite project. This is through MSU Research Consultancy Cell. That is then international TAL grants. These are the project grants, and this is my team actually. Those who have already worked under me. First, that is experimental investigation of drilling of cotton fiber composites. That is during from 2011. Then Dr. Idel, she is in Navratna. Experimental investigation on the tribo behavior of cotton fiber. Tribological, we have developed the natural fiber composites, and where we want to, we have developed, we have tested using tribometer, coefficient of friction and losses, weight loss. Then experimental investigations, that is extension of first, that is in terms of hybrid. Then development of processing techniques and experimental investigation on wear behavior of aluminum metal matrix composite. I think we are just waiting. The patent is under examination. I think within 1 or 2 months we'll get the patent for this. Magnetic stirring we have developed for this. Then mechanical characterization and modeling of unidirectional reinforced polymer composites. Here we have focused more. This is actually somewhat extension what I have worked in 2004 to 8. That is interface and interface, more towards analysis part. And then investigations of process parameter in vacuum assisted resin. The setup that we have developed using Guchko's grant. That is right now she is production manager in mass transport Reliance recently Camrock, that is, so after PhD she was adopted by them due to this work only. So that is achievement of our laboratory. Then Dr. Vijay Parmar, this is more towards the thermal characterization. And then these are the students, those who are pursuing the PhDs under me right now. So this is about, and these are the patent publication. Recently we have granted, and right now it is one patent is under examination, and one patent we have just filed the RQ. So this is about the work that we are doing in our laboratory, and just few slides that we have started the work, prosthetics and orthotics. So this thing we have just targeted and defined these terms. That is shoulder disarticulation. First we have to concentrate on this diagram. Your right side, your left side, and you can see that too much scope is there. How we can thought of, and every day we are having some pain or it is to be replaced. So it is very difficult because we being an engineer, sometimes it is very difficult to understand the terminology of medical terms. So we have started these things, and we are we want to accelerate in this field now. Conventional composites we have just slowed down. This already we have developed and prepared. So now it is open for discussion and your suggestions, because you all are senior and
May I ask?
yes.
Recently, my wife has gone ligament repair.
Upper
What they have done, they have put on screw and they put thread in other places, like microsurgery. But what doctor is telling is this screw will be dissolved in due course of time. It is a composite material.
Yes.
So I don't have any knowledge.
Yes.
But what he is telling that it will be dissolved.
Yes, it is true. Even
What type of material it is? You are
it will be a polymer only, special polymer. It will be a polymer material.
And second question is that if you say a composite material, if you make a V notch, because I was saying
V notch.
V notch, cutting V notch.
Yes, yes. For impact testing.
In material I have done, I actually in 1969, I did BTech from NIT Durga. So there are V notch applied
Yes,
mechanics.
correct. I
And
thought
V notch
that-
for material, we have analyze and do it. But for composite material,
Composites,
it's a-
yes, it is possible, and standards are available.
So
STM
that
standards.
is that.
Yes,
You have
it's
knowledge,
available.
but I don't have any knowledge.
But if you want, I can give you. Standards are available, like ASTM,
Because space distribution will be different.
Yes.
Huh?
Yes.
But space distribution will be different.